A natural number is an integer. Always, sometimes, or never. Always. Yeah, so if it falls underneath the umbrella, it's always going to be part of the one above it. So natural numbers are always integers. An integer is a natural number. That's sometimes, yeah. If it's like 3, that's actually an integer, but it's also a natural number. But if it's 1/3, that's an integer. Or -1, that's an integer, but it's not a natural number, right? So there are some integers that are natural numbers that are some are not. So sometimes an irrational number is a real number. Always. They're all real numbers so far. We'll get into an imaginary, but not yet. A radical whose radicand is not a perfect power is a rational number. Say that 5 times fast. A radical is a root. Radicand is the guy in the root. The radicand, the guy in the root, does not have a perfect power. Example, square root of 5. Is that a rational number? Never. Remember, the only radicals that fall into your rational are perfect ones. So square root of 9, that's a 3. So obviously that's going to be rational. Square root of 25, that's going to be a rational number. But square root of 3 or square root of 5, something that doesn't have a perfect, is not. It's going to be non-repeating, non-terminating. Okay? All right. The product of a non-zero number and its multiplicative inverse is 1. A number and its multiplicative inverse is always 1. The sum of 2 even numbers is an even number.
Always.
Yeah. Because if it's going to be divisible by 2, you're going to add something divisible by 2, you're going to get something divisible by 2. All right? The sum of 2 odd numbers is an odd number.
Never.
Yeah, that never happens because each of them is going to have an extra 1, right, from being away. And when you add them, you're going to have 2, which is then divisible by 2. The product, that's multiplication, of 2 even numbers is an even number. Always. The product of 2 odd numbers is an odd number. Always. The quotient, division of 2 integers is an integer. Is it closed? Sometimes it is, right? Sometimes it's integers, sometimes it is not. Sometimes it's going to be a fraction, which bumps you into rational, right? Sometimes. The quotient of 2 integers is an irrational number. Never. That is a closed set. It will give you at least a rational. Real numbers and their operations, all right? So when you think about real numbers, we have just talked about all the number sets. That's all your rational and irrational numbers. And so you can add, subtract, multiply, divide, and you can have a base and an exponent. These are the basic operations that we have learned that we do with all types of numbers so far. All right. We've also talked about absolute value. Absolute value can be thought of as the distance to 0. It's technically the definition. So distance is always positive, which is why your absolute value is always positive. You're talking about how far away from 0 the number is. Always positive, right? If I say I am 15 feet away from Lewis, I would not say Lewis is negative 15 feet away from me because it's a distance. I would just say he's also 15 feet away from me. So it's just a distance away from 0, which is why it's always positive. And so adding positive and negative numbers yields these rules. So if you'll recall, when you're adding numbers, if they have the same sign, you're just going to add their absolute values and keep the sign. So -2 plus -3, those have the same sign. They're both negative. So you add the 2 and the 3, you get 5, and your answer is negative because they were both negative. 2 plus 3, they're both positive. You just add the 2 and the 3, that's 5, and your answer is positive because they were both positive when you started. So if you have the same sign, just add them, ignoring the sign, and then your answer will be whatever the sign was of those two numbers. When you have different signs, then you are going to subtract, all right? So anytime your signs are different, you're going to subtract, and you just keep the sign of the larger absolute value. -5 plus 3. One's negative, one's positive. You just say 5 minus 3, that's 2. But the negative was on that 5. So then your answer is going to be a -2 because your 5 was the negative. All right? You can think of it as travel. If you have a -5 plus 3, you would go -5. Oh, wait, I'm backwards to y'all, right? -5 in that direction, and then you'd go back 3. You'd still be in the negative realm. You wouldn't have gotten back across 0. So you can also think of it as movement. You went 5 in the negative, 3 in the positive. You're still in the negative because you didn't get back out. You can think of it as money. You owe $5. You get 3. You still owe $2. Okay? Questions on basic operations. So we're going to apply all the rules, including our same sign and different sign from multiplication. And we're going to do these examples. So hopefully everybody can do 5 times 6. 5 times 6 is 30. One of those is positive. One of those is negative. So this is going to end up giving us a negative 30. Decimals. What's the rule for decimals when I'm adding decimals? What do I need to make sure I want to do? Line them up, right? In this case, I have a positive and a negative. Negative 2.4, positive 10.1. So I'm going to line these up. That's the rule for decimals. Because one is positive and one is negative, I am going to subtract. All right? Hopefully we'll all remember our sharing here. So we're going to go over, right? 11 minus 4 gives us what? It's right. It's 7. All right? And then we have 9 minus 2 gives us 7. 7.7. Is this going to be positive or negative?
Positive.
Positive. Why? Because my 10 was positive, right? So this guy's going to stay positive. All right? The next one, I am subtracting here. Now, remember subtraction is technically adding the opposite. This is really important when you do something like C. I have 34 minus a negative 5. Subtraction is adding the opposite. So I am going to say that is adding the opposite of negative 5, which is adding a positive 5. So anytime you have crazy addition and subtraction going on, you can always change your subtractions to adding the opposite, and it may help you. So now instead of 34 minus a negative 5, I just have 34 plus 5, which makes this a much easier problem. That gives me just 39. And I was adding two numbers with the same sign here, positive 34 and positive 5, positive 39. All right, let's look at the next one. I am dividing fractions. What do I do when I divide fractions? What's my little rule? Keep, change, flip, right? And so I'm going to keep the first one as a negative 2 over 3. I am going to change this division to multiplication. And then I am going to flip my second guy, which is negative now 5 over 4 instead of 4 over 5. With multiplication and division, I usually decide right away what my answer is going to be as far as positive and negative, so that I don't have to think about that at the end. What is this answer going to be, positive or negative? It's a negative and a negative. Positive, right? So positive. So then I don't have to worry about putting a negative sign. I can just do my multiplication. Once I've done this, I can do two things with fractions. If I can cross cancel, with multiplication, you can cross cancel, meaning you can reduce across or reduce down, right? Any numerator to any denominator can reduce if it is multiplication. If you do not do that and you just multiply straight across, that's fine, but you will have to reduce at the end, all right? So we're going to look, the 2 over the 3 cannot reduce. The 5 over the 4 cannot reduce, but what can reduce? The 2 and the 4. So I can say, well, I know that 2 divided by 2 is 1 and 4 divided by 2 is 2. And I can cross cancel. And then once I've done that, I just multiply across. Multiplication is straight across. 1 times 5 gives me a 5. 3 times 2 gives me a 6. I already decided at the beginning that this was going to be positive, so I am done. 5 over 6. Keep, change, flip for multiplication, division of fractions. Change it to multiplication. The last one is everyone's least favorite by far. Adding and subtracting fractions. Always people's least favorite, right? We don't even want to deal with it. But what do you have to have when you add or subtract fractions? A common denominator, right? And so we're going to say negative 1/3 minus 3 over 4 plus 3. Couple ways to do this, by the way. You can get a common denominator across all of them. What's my denominator on 3 right now? It's just a 1. Or you could deal with the fractions and then deal with the whole number if you wanted to. I personally get a common denominator all across. That's just my method for doing it, just because then I can just go straight across to my addition and my denominator I already know, and then I worry about reducing at the end, okay? And I don't even make you change it to a mixed number, right? Just leave it as an improper fraction for me. So my method is just to go ahead and fix it. The other thing I would do here is I would do adding the opposite. Because most of the time your errors in positives and negatives come when you have a negative minus a positive. Because then your brain does something where you subtract them and all this. So I would actually change this guy to adding the opposite. And then you're going to see that you have a negative plus a negative. And then you're going to have a positive that you're going to subtract from. All right? So if this guy is over 1, I have 3, 4, and 1. What is my common denominator between 3, 4, and 1? It's 12. All right? And so I'm going to go ahead and make all of my denominators 12. All right, and then I'm going to see what do I need to get there. So what do I have to multiply this 3 by to get a 12? 4. So I'm going to multiply the 1 by 4. My numerator here is then 4, right? What about this 4? What do I multiply that by to get 12? 3. So what's my numerator here? 9. And what do I have to multiply this 1 by to get 12? 12. So 3 times 12 is 36. And so now I have, fairly simple, right? So negative 4 plus negative 9, what is that?
Negative 13.
Right, so I have a negative 13 and a positive 36. I'm just going across, right? If I have a negative 13 and a positive 36, what do I do there? One positive, one negative with addition. Different signs, you subtract. What's 36 minus 13? Right, so it's going to be 23, right? 23. Positive or negative?
Positive.
Positive because my 36. Now, you are welcome to leave it that way. 23 over 12. I am not going to require 1 and 11/12, right? Because when we get into larger problems, you're going to use it as a fraction. If you had to go on from here and multiply or add or whatever, you would want it as an improper fraction. So you are welcome to leave your answers just like that, as long as you can't reduce it, okay? Had this been 26 over 12, I would have wanted you to reduce it, right, by 2. But 23 over 12 does not reduce. I don't care if it's a mixed number. In fact, if you convert it to a mixed number and you do it incorrectly, you'll actually get points off. So just FYI. You're welcome to, but I will take it just like that, 23/12. All right. Hopefully your review is order of operations. PEMDAS is what a lot of people have learned. They've changed it from parentheses to just basic grouping. You do all your groups first, whether it is in parentheses or whether it is a numerator or a denominator over with a division, right? So if you have a division sign, that automatically reduces groups the entire numerator and it groups the entire denominator, okay? So anytime you have a division line, it's going to group it when it's written like a fraction. If you have parentheses, if you have brackets, if you have a square root over a group of numbers groups everything in the root. So there are different ways to group things besides just parentheses. Keep that in mind. But for memorization, we've always said parentheses. The next thing you do after parentheses is any exponents. So any exponents that you have, you're going to do those next. You're going to do multiplication and division. Hear me out. You do not do all the multiplication and then all of the division. This is together. You'll notice in our chart, it's together. Multiplication and division from left to right, whichever comes first. The same thing is true of addition and subtraction. You do not do all of your addition and then all of your subtraction. You do whichever comes first from left to right, just like you would read it, okay? And that is your basic order of operations. So if I were to look at example 2, I have 2 plus 4 times 3. What am I going to do first? The multiplication. All right, I don't have any grouping. I don't have any exponents. The next thing I do is multiplication and division. My multiplication and division here, well, that's this guy. 4 times 3. What is 4 times 3? Yes, it's 12. Now I just have addition, so my answer here is going to be 14. All right, look at the next one. Do I have grouping? I do have grouping. I have 2 sets of grouping. So when I do this, I'm going to do this grouping first. What is 1 minus 3? Negative 2. What is 4 minus 3? 1. What's my next rule here? After grouping, I do. All right, let's talk about exponents. I have two things with exponents. I have a negative 2 to the fourth, right? What's the difference between the first negative 2 and the second negative 2? What's the difference between those?
The second negative 2 is multiplying the 4 negative 3.
I mean in this one. So in this line right here, what's the difference in this guy with a power and this guy with a power? It's a visual difference. You should see something different between these two. There's parentheses. Why is that important? This is the number one mistake adults make when they're doing this problem, by the way. The key here is, for this one, you take the negative 2 and you multiply it 4 times. Negative 2 times negative 2 times negative 2 times negative 2. All right? This one you don't. So you are not actually squaring the negative. You can think of this guy right here as negative 1 times 2 squared. That's technically what that is. It is the opposite of whatever answer you're going to get. That is the rule there. So how does that change it? Well, if I did negative 2 parentheses squared, I would get a positive 4. But if I do it this way, what am I going to get? A negative 4, because my order of operations says I'm going to square that 2 first, and then I'm going to apply the negative. In the next group, it's actually grouped. I'm going to apply the negative first, and then I'm going to square it, okay? So it forced an order of operations here using that parentheses. It matters. It wouldn't matter if it were to an odd power, because it would be negative either way, but it does matter if it's to an even power. It will change your answer, okay? So this is going to make a difference. I actually need to do the things that are grouped first. So that means I need to do this guy before I square it. Now you can do them all, but keep in mind that when you square this, 2 squared is 4, then apply the negative. That's going to give me a negative 4. Negative 2 to the fourth power is going to give me positive 16, because it's negative, 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 negative. 4 negatives is going to give me a positive. All right, so that's positive 16. And then I have a negative 2 and a positive 1. That's negative 2 right there. Now, I don't have any grouping, exponents, or multiplication, division. I'm just going to add, subtract from left to right. Okay? And so I'm going to say negative 4 plus 16 minus 2. That's going to give me a 10, positive 10. Negative 4 and 16 is negative 12. Or positive 12 minus 2 is 10. All right? Questions on that one? Most adults would miss this, honestly. They mess up order of operations, the most common mistake ever. Yeah, so another thing that can group something is absolute value, all right? Absolute value will group it. So this is considered a grouping. And so I am going to do what's inside my absolute value first. 3 minus the absolute value. What is 2 minus 8?
Negative 6.
Negative 6. And then I'm going to apply the absolute value. The absolute value of negative 6 is positive 6. So it's not 3 minus the absolute value of negative 6. I'm going to just say 3 minus positive 6. Different signs. So what am I going to get here? 3 minus 6.
Negative 3.
Negative 3. All right. So when we're talking about the number of terms, we're talking about polynomial type things or addition and subtraction of different terms. Couple things about terms. One, they can be multiplying, dividing, but you don't count them separately if they're grouped. So the first one's easy. Obviously, that just has one term in it, 2x. 2x is just one term. But if I look at B, I'm going to say, well, I have an x, a 4, and a y. Well, that's only two terms because the 4 and the y are being multiplied and they're grouped together with that multiplication. If I look at C, this also only has two terms. This 2xy is one term and this whole thing right here is one term. All right? Even though if I distributed it, it wouldn't be. But right now it's only considered two terms. All right? If I look at this last one, I have 1, 2, 3 terms. That's considered 3 terms the way it is written right now. All right? 3 terms. The next thing that we have here is substitution. So if you look right below that in your book, we have the substitution property. You use this all the time. You just may not realize it. Anytime you are solving a basic algebra equation, you are using substitution in some way, shape, or form. Okay? In this case, we're going to use order of operations and we're going to substitute the variables for numbers. So they have given us these algebraic expressions, and then they have told us which each of the variables equals. Anytime something equals, you can put it in place, just like it was its own thing. So for my volleyball girls, when y'all substitute out, if I'm not mistaken, they have to substitute in the same place. That's how it is in most sports, right? And so you can't substitute one for another. They have to play the position, okay? With math, it's the same. You have to substitute in. If x equals 2, the only place you can put 2 is where an x is. And you actually need to put it every place the x appears, okay? And so then once you substitute all of your variables, you're just going to use order of operations, what we just did. So let's look at these. We have x squared plus y minus z, and they have told us what all 3 of those equal. And so we're going to fill it in, and we're going to solve. All right, so let's look at A, x squared. Instead of x squared, we're going to write 2 squared. Now, we just showed why parentheses matter. When you plug it in, technically it's parentheses. It won't make a big difference here, but it would if that had been a negative 2. All right, so had this been a negative 2, I would not have written negative 2 squared. All right, if it will let me write negative 2 squared. That is not what I have written. I would have written something like this. So if you're plugging it in, it is automatically parentheses inside there. All right, in this case, it won't matter because it is a positive 2. So I have 2 squared plus my y is negative 3 minus my z, which is 1/4. All right, what's the first thing I'm going to do? I don't have any grouping, which negative 3 is kind of parentheses, but there's nothing inside. So we're going to move right on to exponents, right? 2 squared is
4.
Plus negative 3 minus 1/4. I would probably go ahead and do these first. Why? 4 plus a negative 3 is 1. 1 minus 1/4. I don't actually have to get a common denominator if I don't want to, but I can because I actually know this is going to be 3/4 left over. Anytime you just have a 1 with a fraction, you can just put denominator over denominator. So it's going to be 4/4 automatically. Minus 1/4 is going to give me what?
3/4.
Yep. And I am done. All right. That one wasn't so bad. Let's look at the next one. The reason I'm choosing to do the next one here is because I'm going to have a fraction thrown in a fraction. So once again, I have x squared, that is 2 squared, minus y squared. Y is negative 3. Here's where I'm going to want to make sure I do that guy right there. All right, because that will make a difference. Over x, that is 2, and z, that is 1/4. They were actually nice. That's going to be beautiful once we do it. All right, so anytime I have numerator denominator, it automatically groups. That means this guy is grouped. This guy we have to do first, all right? So 2 squared gives me a 4 minus negative 3, if the group is squared, gives me what? Positive or negative 9?
Positive 9.
Yeah, so positive 9. 2 times 1/4 is 2 over 1, 1/4. That should give me 2/4, which is reduces to 1/2, all right? What's 4 minus 9?
Negative 5.
Negative 5. All right. What do I do here? What is this? This is just a division, right? What did I say before when I divide with a fraction? I do what? Keep, change, flip. When it looks like this, I keep the top. So I'm going to keep that -5. I am going to change it to multiplication, and I'm going to flip the bottom, which is going to be 2/1. Another way to write 2/1 is just 2, right? So I have -5 times 2, -10. All right? And we would do that all the way across. I don't think we run into anything else really unusual here. One thing I do want to point out for this one right here, z is 1/4. If I square a fraction, what do I need to do? Square both of them, right? 1 squared and 4 squared. So that would be 1/16. So just keep in mind when you're squaring a fraction, you just square your numerator and your denominator. But other than that, that is your filling in and solving. So try 2 of them. And I gave you some fractions in there just for fun. If I have Celsius and I want Fahrenheit, so you may want to write these down. So I want my answer to be Fahrenheit and I have Celsius. I'm going to say 9/5 times my Celsius temperature plus 32. If I have Fahrenheit and I want Celsius, then you're going to kind of do the inverse is what you do. You actually do 5/9, so your fraction is flipped. But you do have a parentheses here. And you take your Fahrenheit and you subtract the 32. The only time this makes sense in my brain is for 0 and 32 degrees, I have to be honest. It's about the only time it makes sense. They want us to convert. They've given us Celsius. They want Fahrenheit. So we are going to use the first one here for A. All right, so for A, I want Fahrenheit. I want to know what my Fahrenheit is. I'm going to say 9/5 times my Celsius temperature, and then I am going to add 32. Once again with fractions, what's nice for them giving me something like 15 is that it's going to cross cancel. The 5 can cross cancel with the 15. 9 times 3 is 27, thank you, plus 32, and that's going to give me 59 degrees Fahrenheit, right? So 15 degrees Celsius is 59 degrees Fahrenheit. And then vice versa, look at B. They want me to go back, not from the same temperature, obviously, but they've given me Fahrenheit and they want Celsius. So for this one, I'm just going to plug it in. 5/9, my Fahrenheit is 15 minus my 32. And again, I'm going to do order of operations here, right? I did it up here. I did my multiplication, then my addition. Here I'm going to do my grouping. 15 minus 32 is -17. And I'm going to multiply that by 5/9. This is not as pretty, by the way. It's going to be a weird fraction. So we're going to get 5 times 17 is 50, 85? So I'm going to get -85/9. This is actually one place where I wouldn't leave it this way. I would actually do a mixed number, because if you say something's negative 85/9 degrees, that makes even less sense, right, in your brain. So you would want to do this as a fraction or decimal, because that doesn't make sense. Like measurements don't make sense as improper fractions. And so you get -9 and I think 4/9, right? So -9 and 4/9, which also is a weird temperature. So I think they put it in a fraction form. It is rounded there, but that's actually Celsius, not Fahrenheit. My thing says Fahrenheit. That should be Celsius. All right. So -9.4 degrees Celsius